In continuation of our report with the topic Vibrio, we will be discussing another species from the family, which is Vibrio vulnificus. Here is the picture of Vibrio vulnificus. So Vibrio vulnificus is a gram-negative bacterium found in warm, shallow coastal waters of the Atlantic, the Gulf, and the Pacific coasts of America. It is first discovered in 1979. After cholera, it is the second most serious type of Vibrio-associated infection, um, and it uh, causes two uh, infections that fell into two categories, which would be discussed later in the slideshow. So, as according to CDC, 1 in 7 people who are infected with Vibrio vulnificus dies, and others require intensive care or even limb amputation. So that is how serious it is. So how do we get Vibrio vulnificus? So, like I said earlier, there are two infections, two categories of infections. The first one is the primary septicemia. Septicemia is the blood poisoning caused by bacteria, which is the extreme response of our body to any bacterial infection. In simpler terms, it is sepsis, or our blood inside our body will become toxic. So, primary septicemia caused by Vibrio vulnificus occurs through the gastrointestinal tract after shellfish consumption, specifically the eating of raw oysters, and it can develop within hours with a mortality rate of 40% to 60%. Patients with liver dysfunction and syndromes that result in increased serum levels of iron are particularly predisposed to this scenario. The next category of infection would be the wound infection. Patients with Vibrio vulnificus wound infection invariably have a history of some type of traumatic aquatic wound that often presents as cellulitis. And when it would be when the infection would progress, such cases have been documented to necrotizing fasciitis, where the bacteria is eating the flesh inside our body, or it can also cause organ system failure. Although these infections can occur in healthy hosts, most serious cases are affecting the immunocompromised individuals and those who have experienced a mild to severe injury to the infected site. So here is an example of a infection of Vibrio vulnificus through wound infection. So as you can see, it presents cellulitis. Some parts of the flesh were eaten. It's really serious. That's how lala it is. The next species that we will be discussing would be Vibrio alginolyticus. So out of the four major Vibrio species, it is the out of the four major Vibrio species likely to be encountered in the laboratory, Vibrio alginolyticus is the least pathogenic for humans, and this species is also the most infrequently isolated. So it is a common inhabitant of marine environments and is a strict halophile, meaning it requires at least 1% of sodium chloride so that it would be able to survive. It is able to tolerate up to 10% sodium chloride. So laboratory diagnosis. First, we have the specimen collection and transport. Vibrio alginolyticus, or Vibrios as a whole, are not fastidious, meaning they do not require um, specific guidelines or conditions for it to survive. And only a few special collection and processing procedures are only necessary to ensure the recovery of Vibrios from clinical material. So whenever possible, Bodily fluids, pus, or tissues should be submitted, but swabs are acceptable if they are transported in an appropriate holding medium. Here, swabs are acceptable given that it would be delivered in a appropriate holding medium such as the carry blair. This would prevent desiccation. Buffered glycerol-saline mix buffered glycerol-saline is not recommended as a transport because glycerol is toxic for Vibrios. And then strips of blotting paper soaked in liquid stool and placed in airtight plastic bags with a few drops of saline to maintain moisture is viable or considered viable specimen that would last up to 5 weeks. Stool specimen should be collected early as possible in the course of the illness and preferably before the administration of antimicrobial agents. For the culture media, so we have the salt concentration is commonly used since, like we said earlier, Vibrios are halophiles, meaning they require a little percentage of salt to survive. So salt concentration is commonly used in the laboratory, 0.5% salt concentration, and nutrient agar or sheep blood agar is sufficient to support the growth of many Vibrios. On sheep blood agar or chocolate agar, Vibrios produce medium to large colonies that appear smooth, opaque, and iridescent with a greenish hue. And the plate should be examined for the presence of alpha or beta hemolysis, whereas on Macanchi agar, the pathogenic Vibrios usually grow as non-lactase fermenters. However, lactose fermenting species such as vulnificus, Vibrio vulnificus, may be overlooked and incorrectly considered to be the members of the family Enterobacteriaceae, such as Escherichia coli. So here is an example of Vibrio alginolyticus on a sheeplet agar. As you can see, there is this greenish hue surrounding it. It looks smooth, it looks opaque, and it is iridescent. Maybe it cannot we cannot clearly see the iridescence of the picture, but yeah. Another culture media that is used, especially when selected medium is needed, is the thiosulfate citrate bile salt sucrose agar. So, or the TCBS agar that differentiates sucrose fermenting yellow colonies on certain species such as Vibrio cholerae, Vibrio alginolyticus. Yeah. Um, Although when using the TCBS agar, it should be monitored with stringent quality control measures. So this is an example of Vibrio alginolyticus on thiosulfate citrate bile salt sucrose agar. The presumptive identification, due to its size and its appearance, Vibrios as a whole can easily be confused with the other genera such as the Aeromonas and the Pseudomonas. Thus, general susceptibility to vibriostatic agent and positive chain test separates them from Aeromonas. Inability of inositol fermentation separates them from Plasmomonas. Positive oxidase reaction distinguishes Vibrios from Enterobacteriaceae, and the carbohydrate fermentation metabolism distinguishes Vibrios from the oxidative Pseudomonas. So these key tests can aid in the initial identification of the Vibrio isolate, since, like I said earlier, it can easily be confused. Here we have the rapid and semi-automated identification system. So, although these identification systems contain databases of the more commonly encountered clinical vibrios, they are generally inadequate for accurate identification, particularly that those are less commonly encountered. In particular, their unoculating suspension should contain at least 0.85% salt or sodium chloride, such as the such as what is found in the API-20E identification strips. Even then, halophilic species might grow poorly or confused with Aeromonas. So most authorities advocate identification with conventional biochemicals, supplemented with additional sodium chloride if warranted. We can also use D16S ribosomal ribonucleic acid sequencing as an accurate way to identify most Vibrio species. However, because of the rare isolation, this method is infrequently used in clinical microbiology laboratories. MALDI-TOF, or matrix-assisted laser desorption ionization time of flight mass spectrometry, is a rapid, cost-effective means of identification. So yeah, this method has demonstrated accurate identification of the species Vibrio parahemolyticus. So we could molecular typing. There are molecular methods that are available for typing Vibrios. We could use pulse field gel electrophoresis, which is used for surveillance purposes. We could also use ribotyping, multi-locus sequence typing, and repetitive exogenic palindromic PCR, which are available. However, in the future, it is believed that these methods will be replaced with a whole genome sequencing. So I hope that we will be able to somehow reach the point where we would be able to use these types of machine that make somehow our medtech life easier. Antimicrobial susceptibility. So both the I'm sorry for the mispronunciation. The Miller-Hinton agar and broth contain sufficient salt to support growth of the Vibrio species, which are most often isolated from clinical specimens. The recommended antimicrobial susceptibility testing methods are the Kirby-Bauer, which is a standardized disc diffusion or dilution susceptibility testing methods. So the CLSI, or the Clinical and Laboratory Standards Institute, has interpretive guidelines only for Vibrio cholerae, limited to ampicillin, tetracyclines, trimethoprim, and chloramphenicol. Generally, most species or most strains of Vibrio cholerae are susceptible to doxycycline and ciprofloxacin. The increased resistance from the acquisitions of plasmids is relatively uncommon in the US, but there are reports of multiple resistant strains from Asia and Africa. Uh, However, because most vibrios grow rather rapidly and are similar to enteric bacteria, it is often useful for a first approximation to use the interpretive guidelines for the Enterobacteriaceae when testing vibrio isolates, other than Vibrio cholerae, for agents not clearly covered by the CLSI documents. Generally, fluoroquinolones alone, or the synergistic combination of ciprofloxacin and cefotaxime, display excellent in vitro activity against Vibrio vulnificus strains. And also, most Vibrios are susceptible to gentamicin, tetracyclines, chloramphenicol, monobactams, carbapenems, and fluoroquinolones. So this is where I end. Thank you so much for listening.